Hi guys, today we are going to solve the very famous two-sum problem. We will be discussing the two approaches to solve this problem, and let us start with the understanding the problem statement. So let us understand through a very realistic scenario. Imagine you are in a supermarket with a list of items to buy, right? You only have a specific amount of money and you need to find exactly two items that adds up to that amount. So how do you do it? So this is what the two sum problem is all about. So basically we have been given an array of integers and integer target. So we need to return the indices of two numbers such that they add up to the target. So we can assume that each input would have exactly one solution and we may not use the same element twice, right? Like we can understand it through the example itself. Like we have given a nums array 2, 7, 11, 15 and the target value we have been given as 9. So basically 2 comma 7 makes up the target 9. So what we need to return is the indexes which sums up to the target, like 0th index 2 and the 7 is on the first index. So this is only the thing we need to return. So let's talk about the approaches, how we can think of the approach, or what should be the thought process in order to solve this. So first of all, we need to think the brute force approach, like how we can do that. So basically the thought process should be like by just checking all the possible pairs we can do that. So thought process is like first of all we need to take each number and check all the other number to see if their sum matches the target. If we find the pair, we simply return their indices. For example, in this logic, like we need to use the two for loops, basically two nested loops. So first of all, we will traverse our we will traverse our array, like for loop for picking up the first element. Then again, for the second element, we need to have a nested for loop, and we will iterate it over the one element next to the ith one, that is the bigger for loop. So we will iterate over it, and we will also add the if condition, like if nums of I plus nums of j equal to target. So basically this is the condition we check, like if the sum is equal to the target, we simply return the indices of those elements, correct? And if by any chance we didn't get the required target, so we will return the empty array. So the time complexity for this approach should be like, first of all we are running the bigger for loop for first element, then for the second element. So basically it will be, the time complexity will be like O of n squared due to the nested loops we are using it here, and space complexity will be constant as we are not using any extra space. So let us go through the code first of all in order to understand the brute force approach in much better manner. So first of all, what we did basically, like we have added all the standard libraries, then we created a function to find two indices whose value sums up to the target. So basically we are creating a vector in two sum, like we are adding up the parameters here, like n is the number of elements, and then vector in the array, and the third one is the target we want to get. Okay, so we are also creating the vector, one more vector in order to store the indices of two elements. Basically this is the answer, so we are storing it over here. So we are similarly as we discussed in the logic beforehand. So we are using for first for loop for the first for getting the first element, then the second for loop from I plus 1 indexes, then till the n number of elements, and second loop starts from I plus 1 to avoid duplicacy. Again we are using if condition for checking the if the sum matches with the target, and if it happens, so we will straight away push back our first element's index and the second element index. Otherwise we will be returning the indices as soon as we find a valid pair. So if we don't get into this condition, so we straight away get out of this and we will return -1 because there is no valid pair found. So we will come to the main statement. just a second, we will go to our main statement, like we are entering just a dry run for this. So it will be containing the number of elements. So suppose we have a number of elements is equals to 5, and then vector, we are initiating an array of 5 integers. So this is the input array, and the target we are taking it as 19. So we are calling the functions directly over here, like vector int answer we have created, and the to sum, we are directly calling the parameters here, like we have initiated it over here and we are directly calling it here. So we will print the result like answer of 0 comma answer of 1, because we have already initiated the vector int answer for getting our final results. So answer of 0 will give the first index, and answer of 1 will give the second index, and the required answer we will get it as, for example, in case of this input, so we will get like 19 by 19 we will get 11 plus 8. So basically we will get the output as 3 and 4. So basically I will be going to run this code. We will be getting 3 comma 4. It is taking time. So answer we are getting 3 comma 4. So this is the basically brute force approach the one should know before getting towards the optimal solution. So now I'm heading towards the second approach, which is quite optimal. So how we can think of it, like the earlier approach was taking n square time complexity. So approach second should be like, what if we remember the numbers we have already seen by using the HashMap approach. So the thought process should be, we should use a HashMap or an unordered map to store each number as we process it through our array. So for each number, we need to check if the target, that is target minus the current number we are at, is already in map with the help of the find function. No need to worry about this statement. I will be discussing over here in itself in the code. So if we found the element, we will straight away return the indices. This method is quite optimal, but using an unordered map. So let's discuss the code so understand it in a much better manner. So basically there will be the similar function definition. We will be initiating the function to sum, and we are getting the same parameters we will be inputting, like vector in nums and in target. So we are initiating an unordered map for this in order to store the numbers and their indices. I'm hoping that you all are getting how unordered map works. Basically it works on key value pairs. We are taking the keys as element and value as indices. So we will be iterating the array one time for int till the last element, and secondly we will be calculating the complement of it, like suppose we are getting target and the target minus nums of I, the current element. This is the current element. The complement will be equal to the target minus nums of I. So this will be giving the other index that we want to get. So we will check if the complement exists in the map or not. If it happens, we will return the index of the complement and the current index element. So this is the find function. Under this we will be using the mp.find, and under this we will be finding the complement that we initiated here. So if we found the complement in the map, then if we don't found the complement in the map, so basically we will return the indices if found. So next, if it doesn't check this condition, then we straight away move out of this and we will just store the current number with its index in the map. So this will be the syntax of it. mp of nums I is equals to I, and finally returning an empty vector if we don't find any valid pair. So the main statement is quite simple, like we are initiating a nums array and nums vector, then we are taking a target, and simply now I will tell you the approach what we are using. Suppose we want the target as 9. So the complement here we have defined is basically what it is doing, like it is iterating over an array, and what it is doing basically, we need in an unordered map, first of all it will start from 2, 7, 11, 15. So first of all as soon as we iterate, we just see like suppose target minus nums of I. In the first iteration, we will see like if the 9 minus 2, that is 7, is already present in the map or not. So the answer is no. We will move ahead, and then we will again see if the target minus like 9 minus 7 is already present in the map or not. If it does, we will return the index. If it is not in present, then we will go further. So basically we saw like in the first iteration 9 minus 2, the 7 was not present, but the second iteration, as we did 9 minus 7, the 2 was already there, already stored in the unordered map, as we did in the previous iteration. So our answer will be 7 and 2, and straight away we will return the indexes like MP of complement, and the second one is I. So in this case we return the 2 comma 7, the indexes of 2 and the index of 7, that is 0 comma 1. So basically this is the approach we are using. First one I'm again explaining you in a better manner. Hope so you will be getting the point what I'm trying to tell you all, like how this complement works. Like suppose you have a target 9. What we are doing is we are initiating a complement variable, and what it does is basically it will subtract the target from the current number. That is, suppose we are having the current number is 2. In the first iteration the current number is 2. So what we are doing over here is we are just subtracting it through the target. Suppose target is 9, and 9 we are doing the complement value will become 9 minus 2, 7. So 7 we don't have it, right? We don't have 7 in the unordered map, but we will store it. Then again in the second iteration we will first of all we don't have 7, but we will store 2 to make the calculations easier for the next iterations. So we will store 2 in an unordered map. Secondly, what we are doing is we will move ahead and we will subtract 9 minus 7, 2. We got the point here, like we got the point here, 9 minus 7 is equals to 2. So that makes that 2 is already present in an unordered map. We will straight away return the index of 2 as well as the index of 7. So this is all about the approach. Then we will declare the vector int result. We will directly store the result in this two-sum function. We are just directly calling it over here. And as in the case of the previous brute force solution, similarly we will see out the result of 0 and result of 1 as we did in previous one. So I hope the approach is clear to everyone, and it is quite simple. Thank you. If you like the video, please like, subscribe and share to the other students.